Let's solve question number 4. Two bodies were thrown simultaneously from the same point, one straight up and the other at an angle of 60 degrees to the horizontal. The initial velocity of each body is at 25 meters per second. Neglecting the air drag, the distance between the bodies 1.70 seconds later is. So there are two bodies were thrown simultaneously from the same point, one straight up, so one is straight up, other one is at an angle of 60 degrees to the horizontal, right? And both are thrown with the same velocity, that is the 25 meters per second. Neglecting the air drag, the distance between the two bodies after 1.7 seconds is. So we have to find out a distance between them after 1.7 seconds, nothing but we have to find out a relative separation between them. So let's draw the diagram for the question number 4, then we'll understand it neatly. Right. Let's see question number 4. So question number 4, let me draw the diagram. So there is a one body which is, let's say, let me try to ground first, right? So let it be the ground, let that be the ground, and we are just throwing one body up and one body making an angle theta, right? So throw one body up like this, and we are just throwing one body with making an angle of theta with this, like so. This is making an angle of theta, which is making an angle of theta here, but both are having the same velocity. Let's say this body is having a velocity v and this body also velocity v, but here on the two bodies there is a gravitation. On the first body there is a gravitation, on the second body there is a gravitation. On this body there is a gravitation g, which is in a downward direction, and on this body also there is a gravitation g that is also acting in a downward direction, right? So this is a gravitation g acceleration, this is the acceleration of this body, right? Both are moving under the gravitation, both the bodies are moving under the gravitation, right? So let's say this find out relative acceleration. If you find the relative acceleration, let's say this is a body A, let it be the body B for understanding, right? That's a body A and a body B for understanding. Now let's say A relative. We have a A relative. A relative is equal to, that will be 0 because both are acting in the same direction. So if we subtract it, that will be equal to 0. A relative is equal to 0. We have A relative is equal to 0, and coming to the S relative, we don't know this S relative, that we have to calculate. And let's say U relative, initial relative velocity between those two bodies. So let's say I'm finding out velocity of B with respect to A anukondi, or velocity of A with respect to B anukondi, whatever, no problem. So let me say I'm finding a velocity of B with respect to A, that will be equal to, I can write as a VB bar minus I can write it as a VA bar, right? So that's the only case that will be helpful to solve the problem. So let me highlight it. That one is important, right? Now listen. So this VB, if you split this VB into components, so there is a one component along this X, and there is a one more component that is along Y, right? And this along a component along a X will be like VB, this will be VB cos theta, this is a VB cos theta, and this will be like a VB sin theta, or you could also say that V cos theta and V sin theta in parallel, because you know the velocity of a V. Therefore this U relative can be written as, this U relative will be equal to V cos theta I cap, V cos theta I cap plus V sine theta g cap, and you know minus VA meaning, that is we have to reverse the direction of minus, so we'll have a minus VA j cap, right? That will be equal to, we have a V cos theta I cap, that will be right as plus V sin theta minus velocity of A, nothing but a V again, so V sin theta minus V can be written as a j cap. Now if I find out the magnitude of it, that will be equal to V square cos square theta plus V square sin square theta plus V square minus 2V square sin theta. That is what we get in a magnitude, and there is under root, right? There is under root. And now this one, this V square cos square theta, V square sin square theta, if I add these two, I can write them as a V square, right? Because you know that cos square theta plus sin square theta is equal to 1. Therefore I can write it as a V square plus, again I have a V square minus 2V square sin theta. Therefore we can write as a under root of 2V square minus 2V square sin theta. And if I can write it as a what, if we take out this V out, under root, I can write the 2 into 1 minus sin theta, right? So this is all what, this is the U relative, that is the U relative initial relative velocity between that A and B, right? Now we have to find out a S relative. We need to calculate a S relative, right? We need to calculate a S relative, so doing it here. That is S relative is equal to, you know the general kinematics formula. Therefore the S relative, so you have a S relative equal to U relative into T plus of A relative T square. So that was the formula to use that relative displacement or relative separation, right? So this logic is important, therefore let me highlight it. So this logic is important. Therefore now I can write as this S relative. This S relative is equal to U relative can be written as V into, or else I can write directly Vt under root of 2 into 1 minus sin theta, right? So do this, you will get an answer. Do the calculation, that is V is given as a 25. This V is given as a 25 into this T is given as a 1.7. That's under root. So 2 into 1 minus sin theta. What is the value of sin theta? Theta is 60 degrees. Theta is sin 60. Sin 60 nothing but again you will have a root 3 by 2 and do this calculation to get an answer. That will be like approximately 22 meters, right? Do it. That is a problem. Hope that's clear.